Hello students, in today's class we'll continue the chapter motion in a straight line and we'll study acceleration, uniform and non-uniform acceleration, average acceleration, instantaneous acceleration, instantaneous acceleration in terms of average acceleration, and we'll derive the equation of motion, that is v is equal to u plus at using velocity time graph. Now, let's define acceleration. The rate of change of velocity of the body with respect to time is called acceleration. Let's understand, if the velocity of a body changes from u to v in time t, then acceleration can be written as a is equal to v minus u by t. Acceleration is a vector quantity as it has magnitude and direction. The SI unit of acceleration is meter per second square. Let's define uniform and non-uniform acceleration. Uniform acceleration can also be said as constant acceleration. The acceleration of a body is said to be uniform if its velocity changes by equal amounts in equal intervals of time. Let's define non-uniform acceleration. This non-uniform acceleration can also be said as variable acceleration. The acceleration of a body is said to be non-uniform if its velocity changes by unequal amounts in equal intervals of time. Next, we'll define average acceleration. The average acceleration is defined as an average rate of change of velocity with respect to time t. The average acceleration over a time interval is defined as a change of velocity, that is delta v divided by time interval delta t in which change in velocity occurs. We can write it mathematically. A is equal to v2 minus v1 by t2 minus t1, which is equal to delta v by delta t, where v1 and v2 are the velocities at time t1 and t2 respectively. Now we'll understand instantaneous acceleration. The acceleration of a body moving with the variable acceleration at any instant of time is called instantaneous acceleration, or the acceleration of a body at a particular instant of time is called its instantaneous acceleration. Let's define instantaneous acceleration in terms of average acceleration. The instantaneous acceleration is defined as limit of the average acceleration as the time interval delta t tends to 0. Mathematically, we can write it as a is equal to limit a as delta t tends to 0, which is equal to limit delta v by delta t as delta t tends to 0, which is equal to dv by dt. Let's derive the equation of motion v is equal to u plus at using velocity versus time graph. For the derivation, let us consider a body moving with a uniform acceleration a. Let small u be its initial velocity and small v its velocity after t seconds. Let AB represents the velocity time graph, as you can see. Now OA is equal to CD is equal to U, where U is the initial velocity, as you can see in the graph. Next, BC is equal to small v, the velocity after t seconds. Let us consider the slope of velocity time graph represents the acceleration a is equal to, what is the slope? BD by AD, which is equal to, we can write this BD as BC minus DC divided by AD, which is equal to, now BC is the velocity after time t seconds. We can write it as v, small v, and dc can be written as u, which is the initial velocity, as you can see in the graph, divided by ad. What is ad? Ad is the time t, small t. Now rewriting the equation, taking t to the LHS, at is equal to v minus u. Now taking u this side, at plus u is equal to v, or v is equal to u plus at. This is the derivation of equation v is equal to u plus at, where a is the acceleration, t is the time, and v is the velocity after time t seconds, and u is the initial velocity. As per your examination is concerned, the equation of this motion derivation is important. In the next class, we'll derive some more equation of motion, that is s is equal to ut plus half at square using velocity time graph, and derivation of v square is equal to u square plus 2as, again using velocity time graph, and we'll study the concept of relative velocity. Thank you.